Welcome back everyone. So this is a code I've used on my channel before, but I'm going to quickly explain it now because I'm using the Raspberry Pi Pico 2. Nothing changes for the Raspberry Pi Pico 2 and the temperature sensor, so everything that I had before is going to work perfectly fine, but I'm just going to quickly go through and explain it again. So the first part, we import machine. So we import machine to make use of the pins. The Raspberry Pi has pins on there. We need to tell it that we want to make use of the pins. That's what that first line is for. Next we have import UTime. UTime allows the Python or MicroPython allows the Raspberry Pi Pico to actually sleep. So we're going to need that. Next we have the temperature equals machine.adc4. So we need to do an analog to digital conversion. And for some reason they've used pin 4. That's it. There's no other real reason. Conversion factor of I've worked this out. This comes from the datasheet of the Raspberry Pi Pico 2 and the Pico 2W and the Pico. This is on the datasheet for all of them. And what we need to do is we need to get the voltage, which is roughly 3.3 volts in most cases, and we're going to divide it by 16 bits. That's the conversion factor. And again, this is something I got from the datasheet. It gives all of this code with the calculation, so it explains everything. A while true loop simply means that this code will run forever and ever and ever and ever unless there's something that stops it. At the moment, there's nothing left to stop it. I've just said do this stuff and keep repeating every 0.5 seconds, but I'll go through and explain anyway. Reading equals temperature.read U16. U16 simply means I'm reading it as a 16-bit value, then I multiply it by the conversion factor, which was this thing up here. So that's why I'm going to get the value called reading. And reading is not a value that we can make use of at the moment. We need to convert that as well. And this again, this formula here was given by the Raspberry Pi Pico datasheet, and it converts a value, the value that we get, to a readable value that makes sense to us. Normally the value is going to be something like 0.7, 0.8, but this will allow it to actually be degrees Celsius for us that we can easily understand. Where it says print temperature, all I'm doing is printing the value of this, so we can see what the actual temperature is. So I can do all of these calculations here and here, but I don't need to print them. I can just do some logic in the program. So I can say, for example, if temperature is greater than 24, then turn the LED on. If it's not greater than 24, turn the LED off. Something along those lines. I'm just printing them because I want to see something on my console so I know what's going on. And finally, I say utime.sleep 0.5. I sleep for half a second. I sleep for 0.5 seconds, and then this code will continue to run and run and run again and again and again. So I'm going to press play on my screen here. Then as you can see down here, my temperature is roughly 23, 24-ish. Just to prove that this is working, this is the temperature sensor on the Raspberry Pi Pico 2W. It's built on there. This is not something that's external. I'm going to put my hand over it, and within a few seconds, hopefully that temperature should start increasing. So I was at 24, I'm at 25, 26 now. Let's see if I can get to 27. There we go, 27. If I remove my hand, it should start going down again. 26 at the moment, back to 25. All right, it doesn't go all the way back down to 24, but that's the Raspberry Pi Pico 2 running with the onboard temperature sensor, which you can make use of, but if you have to do anything really sensitive, I would always recommend to get yourself an external temperature sensor. This is just really good for testing to see what it can actually do.